But I'm here making this video. And on today, I'm going to talk about how much water does it take to propel a person. And I'm going to go more in depth into what I'm talking about. But, you know, we'll see. Let's check it out. Come on. Let's next time. Alright, so today, my person is going to have the oath called Arc Warder. Arc Warder is an oath in the game Deepwoken, right? And this thing is basically Iron Man. This oath should give you an 800-pound suit with jetpacks and stuff, but we're not going to talk about the suit itself. We're just talking about the mass of the suit. It's 800 pounds, right? So it's like around like 400 kilograms. We'll go directly to the numbers later. Okay, so this is the Arc Warder suit. As you can see on the GIF on the left, he's suiting up with the black cold suit from, the game. And he is flame, just like me. Alright, so here's the Arc Warder. It's 4,310 newtons of force due to the 800 pounds of weight, which I converted to kilograms, of course. That's why it's that number. Yeah, here's some physics stuff. Obviously, electroforce and all that, magnetics. You know me. Cool physics stuff. Alright, so here is the person. Here's what propels the person. It's gonna be the Petras anchor. He is holding the anchor and a kite shield. The kite shield weighs 15 pounds and the anchor itself weighs 200 pounds. And the anchor can send the guy forward 6.5 meters in the direction he's facing. Alright, here are my variables. It's just two things. It's weight and displacement. So, right now the weight we currently have is, the first number here being my 431, which is my armor, and body weight, my 91, which is my Petras anchor, and 6.8 for the shield. And we get a grand total of 528 kilograms. And here's my displacement, which is 6.5 meters in 1.5 seconds, which is technically, you could call this displacement, but this is more velocity if you look in the grand scheme of it, because you can just divide it. Alright, so let's go into the waterworks. Get it? Alright, because math is making me sad, I'm gonna cry. Alright, so the mass we are given is 431 kilograms, and the anchor is 91. Yes, we already done through all these numbers. But so far, I actually calculated the speed, which is 4.26. And the way I calculated this is I used an average table, which is like 47.8 inches. And I did the math, and this is 6.5 meters, that distance. I added two tables to each end in my head. And I also did I made this GIF, obviously, so I know exactly the time it stopped and started, which is 1.525 seconds. I know my stuff. And that's how we get the number 4.26 meters a second. And here's mass 1, mass 2, mass 3 times 0. Mass is equal to mass 1 plus mass 2 times velocity of water. That's the equation we're using. Boom. So simplifying the equation, we do this. Substituting the given values. Yes. And then we get the velocity of the water, which is shooting out of me. As you can see, the Petras anchor is propelling the water out of me, which is negative because it's going the opposite direction as me. Alright, now we calculate how much water do we need, right? To propel a person with this much mass. Look at this. So we're doing the momentum of this person, right? So person, anchor, and shield. Now, we should know the velocity of the water. We already have the velocity of water from the last slide. So now we just get this equation right here that I found online. And then we multiply it. We multiply it by velocity divided by velocity of water, which we already have a velocity because I found it earlier. And then we have the velocity of water because I also found that earlier. And simple dimple, we get the mass of the water. Simple dimple. Now, if you want to know in volume,
while Miguel is talking to himself,
I already knew this, of course,
I just wanted to say that little pump, that little container on the right, it could
mass
literally
water
hold
to
all of that
liters,
water. Yeah.
it's just divided
Just
by
for
1, 'cause the
1.5 seconds, it's
density
gonna
of
shoot
water
all that water out.
is just
It will
1
literally
kilogram
hold it all
over 1
for that
liter,
1.5
or
seconds.
something like that.
But it's like crazy. Like that's
So,
how much water we're
Just
talking about.
192
It's a lot of water.
grams
It's kind of unrealistic, but it's a lot of
2
water.
liters of water. So, and then that's it in pounds. Yeah. So this is the challenge that Dr. Allen May gave me. Of course, look at this. Look at this. So I'm gonna give you a breakdown of the picture. This is the Petras anchor, right? And this is okay. This is gonna look really stupid, but the hose is not shooting the water out into the ocean, of course. Let's just pretend, okay? Because I'm not an artist and I'm not gonna Photoshop all night making it look like a full-blown pump system that pumps water into the anchor. But basically, this hose is gonna suck up the water, right? And then fill up, the gallons that we got, or the crazy number, like around 200,000 liters of water into the anchor, which is kind of insane. So we're just gonna say it's like those water jet things, those jet packs, but they're not like using actual fuel, it's using water. It's gonna be something similar to that. It's powered by the ocean. And this one we're gonna say that it's gonna push an 800 no, not an 800, I would say nearly 1,000 pound man. My bad, I'm saying kilograms because I've been seeing that all day. Yeah, so here's my math right now. So the diameter we use, let's just imagine that there is a 0.5 hole right here, right? It pumps the water in, and it just builds up speed. It goes into the circle, and it comes out the hole. Because in the last one, it's splashing out of that backside. So now we can calculate the thing since we have the diameter, the speed of the water, of how much we're using. So that's Q, by the way. That's what Q means. So the formula we're going to be using is, this one. Pi times diameter over 2 squared times the velocity of the person, the object that's moving. And we already got that speed, we got the diameter, so we could just fill it in. And it's really that simple, bro. It's actually that simple. This is the number it's going to be using 0.7132 cubic meters per second. Yeah. And thank you, Roy Mech, because that was actually such a helpful site. Use this for a lot of my stuff. It's a lot about fluid mechanics and stuff. Very useful. You want to make your own Petras anchor in real life, please use this website. I recommend it. Thank you so much. Thank you.